Hi, welcome back. So in this video, we'll be talking about loading assets in Phaser. The template we've been using, in fact, does this quite a bit. If we have a look at the scenes loaded in the template, you'll notice there's a boot and a preloader. And we'll be going over the mechanics or the way it works of these two scenes in particular. But first, I thought I'd just go over a few important points about loading assets. Basically, if you don't understand this straight away, it's okay, because we will be talking more about this. But the gist is that basically in a scene, in your own custom scenes, when you're extending Phaser scene, you can define a preload method, just like you can define a create method to create your game objects, or an update method to define how to change properties on those game objects. So preload, it gets called before create, and it instructs Phaser to start the loader plugin. And we'll be talking more about that, and we'll be seeing the scene manager's boot scene method to get an idea of what's going on a bit later in this video. But basically, the assets loaded in preload are not actually loaded straight away. When you use this.load, that's an asynchronous operation. So instead of loading straight away, you're basically queuing. You're queuing the assets you want loaded, and then the loader plugin will go ahead and load them. On completion, it will fire an event, and that's when your scene's create gets to be called. So when you're running create, you know that whatever you've loaded, whatever you've instructed Phaser to load in the preload, so that's why it's called preload, right? Not load. It's in your scene, you're defining a preload method that gets called before the loader plugin actually loads the stuff, right? You're unqueuing stuff there. And when that's all done, it fires an event and your scene's create method kicks in, basically. Also to note is that loaded assets are cached and available in all scenes. So basically, the way, if we go back to all these scenes that we're defining in the template, right? If I load something in boot, it will be available in preloader, and we're taking advantage of that. So if we have a look at boot here, all we're doing here is just loading the background. So in other words, even if we have a look at the comment here, it's probably saying something to that effect. So the boot scene is typically used to load in any assets you require for your preloader. So any important assets that you want as soon as possible, it's saying basically use the boot scene to load them. So the boot scene has its own dedicated preload method, in which we're saying, listen Phaser, go and fetch assets /bg.png. Okay, and I'm going to key this in the cache as the string background. So anywhere else, so for example, then inside of preload, we are doing this.add.image and using the same key of background, right? And that's how we're able to reference what's been loaded in our cache. So obviously Phaser doesn't go and download this again. All right, so that's basically the whole point of boot, is to get anything essential, anything that is essential as quickly as possible, so we don't load all our game assets. Imagine our game is heavy on assets. We wouldn't want the boot scene to take too long, because the preload, it enqueues all these things and it never runs create until these preloaded assets have loaded, right? Or failed to load. Once they do get loaded, though, create kicks in, and in this case, we're starting the scene as we've seen in the previous video. We're using this.scene.start to start the preloader scene. And as we've seen, that shuts down this boot scene, and it starts the preloader, which now has access to this.add image and can use the background, basically. Inside of which here we are loading any more. So as you can see, there's another preload method. So, okay, in this case, we're just adding one more image, but the whole point then of preload here is to load the bulk of your game, right? So that's why if you inside of init here, there's a little bit more going on. There's a progress bar being displayed. And obviously that would depend on, actually seeing it would depend on you having some assets to load. So we will emulate this just to have a look at how the progress bar looks when we get to it. But it's the same sort of thing, right? The only addition here, there's this init. There's this init method, which gets called actually before the preload. So it's basically as early as possible, it's trying to add this image that we've loaded inside of boot, and it's trying to load it so we can actually see something on the screen, right? So we can see the background we loaded. And then this whole rectangle is how it's doing the progress bar. Now we'll get more into that later. So in preload, it's doing something a bit new, a bit different. It's doing set path, and we'll talk about that later too. But basically, that's in order to avoid doing assets logo.png every time. Imagine you had a lot of assets to download here. You wouldn't want to stay doing assets for every one of them, for example, or maybe you would. I don't know. That's just a convenience. It's just there. It's just showing you it can be done, basically. One thing to know, though, about this is that this .load is scene specific. So then if you go inside another, for example, the main menu scene, right? The one that's after preload, the one that we start from preload here, main menu, then you would have to, if you want assets to be something you can ignore when you're loading the image, you'd have to once again do this .load at set path. But we'll talk about that if we need it later. So that's the idea here, basically. If I go back to the notes, maybe this now makes a little bit more sense, right? The fact that these are asynchronous operations, and that create doesn't get called straight away. Okay, that create, basically you can assume in create that you didn't have access to what you loaded in preload. So over here, as a bit more documentation we can read. So this would be the type of the preload method here. And we read a bit over here. So it can be defined on your own scene and use it to load assets. This method is called by the scene manager after init and before create, but only if the scene has a loader plugin. Yeah, sure. So Phaser can be built without having a loader plugin, or you can opt out per scene to not have a loader plugin, but we will have a loader plugin basically. After this method completes, if the loader plugin's queue isn't empty, the loader plugin will start automatically. So yeah, so we'll see this more in the code actually. So let's just keep it at that. All this is saying though, that I made a small explanation. It's basically saying that if you have used the this.load, then it gets loaded automatically, the loader plugin. It gets started automatically. Okay, so what I've done here is I've navigated to Phaser's src scene manager so that we can have a look at the boot scene method to give us an idea of what happens when we boot a scene. And here it's saying basically that if said scene has an init method that gets called, scene.init.call. Also, if the loader plugin actually exists, right, and the scene has a preload, then we're also calling the preload. And at this point, preload will go ahead and enqueue certain assets for the loader plugin to load. Over here is where the loader plugin gets auto-started, what we've been talking about, right? That this preload has a special ability, quote unquote, is that when after it gets called, this loader plugin gets called automatically. That's what we were saying, right? Also, before that gets started, we're registering such that when the loader completes, when it fires this event, that the scene manager's load complete runs. And all this is doing is running the scene manager's create. And what that's doing then is that is then running the actual scene's create if it exists, right? So if scene.create, then it goes ahead and calls it. So basically it's in code what we've been talking about, right? It's inside the Phaser source code here. And hopefully that gives you a better idea of what we were talking about. Okay, so back to the preloader here. There's this note I didn't really talk much about, and I'd like to address that now. So basically when we were talking about basically using the downloaded image, the background, as soon as possible, there's this note here that says it's doing it in init. But is this as early as possible? Couldn't it have done it in the constructor, for example? That would have been sooner, no? The problem with that is that this .add at that point is not yet available. And that goes for not just this .add, but a lot of things are injected into a scene. They are mixed into the scene, right? So your scene, which is extending scene, cannot rely on everything being loaded yet. So at init you can, but in the constructor you can't. And you can see this very easily by simply trying to use this .add or just console.logging it. So by console.log.add here it is. And I currently have this running. Okay, it's just basically what I've done is I've digited the same template we've been doing all along. And if I go now and have a look at the console, what I should see here is that it's undefined, right? Which is totally expected because as I've said, as we've just talked about, there's a lot of things which are injected into the scene, which you cannot rely on them being available just yet in the constructor. So that's why this is done in the init, not inside the constructor. Right, so back to the preloader. I'm going to try to explain this loading, this rectangle basically. We have two rectangles here, an outer one and an inner one. So I can just go and show this off. First thing I want to do is to disable if you have this uncommented, comment it out, so you don't want to start the next scene. So basically this is how the loader will look when it's fully loaded. And if I were to comment out also the progress, and this is how it will look like initially, with nothing that has been enqueued actually loaded. So if I go back to Figma and have a look at this, this is a screenshot of this part over here. As you can see, there's a small gap in between the inner rectangle, top and bottom, and left and even right when it's completely full, there'll be a small gap on the right edge. So yeah, the reason I show you that is because when you do the math with the given values, that's why they don't add up. But that's how it looks like visually. And now that we know how it looks like visually, I can more easily talk about the numbers and how it's being drawn, basically. So over here, it's just the background, and then we have our first rectangle. This one has a stroke, set stroke style. So basically, it's going to be the outer one. It doesn't have a fill, but it has a stroke. So yeah, that's what that is doing. And this one has a fill instead, the inner one. So they're both white, but one is, as you can see, one is missing over here, the stroke, whereas the other one has, one is missing the fill, but has a stroke, and the other one has a fill and is the other way around, basically. So if you okay, so let's just talk about the numbers real quick. The first rectangle is at 512,384. So 512,384, as you can see, we are drawing from the top left. And so this cross would be the center point, the origin of the first rectangle. And in fact, you could console log out the origin X and origin Y, and it should give you a 0.5, which means that the origin of this object, this game object, this rectangle, is in the middle. And so when we give it a width of 384, when we give it a width of 4 6.8 and the height of 32, what will happen is that it will take the half of that, 468 division by 2 being 234, and it will make the rectangle 234 on the left and 234 on the right, and similarly 32 will be divided by 2, you'll have 16 up and 16 down. And so that's how the initial rectangle is drawn, the outer one. Similarly for the progress bar, the filled one, it's going to pick its x and y. So its x will be 512 minus 230, and that will give you the position of 282. So there's basically 230 in between these two values, right? In between 282 and 512. And then it's also the same y of 384, right? They're both at 384. Both this one and this one. The 4 will be the width, so it'll go basically this one will be 2 on the left and 2 on the right pixels, and 28 divided by 2, and that will be let's see, 14. So 14 on the top and 14 on the bottom, and as you can see, they don't add up to 32, right? So that's why we have the gaps, as we already saw. So that's basically how these things are being drawn. What may be a bit confusing now is that, sure, I talked about the rectangle being in the, the origin being in the middle, and then you go to the left, half the width, to the right, half the width. But that is not what happens when we see have a reference to bar here, and on progress we are incrementing the width. And as I mean, let's talk about this now. That the width is being incremented based on the outer rectangle's width, right? That we multiply by progress, which would be a value between 0 and 1. So eventually, you'll fill up basically it'll fill up the bar. But the point, though, that I was initially talking about, that I wanted to bring your attention to, was that here we're incrementing the width, but it's incrementing, its right edge is incrementing towards the end, right? Whereas before, on the initial render, on the initial drawing of the rectangle, the width that we give it is actually divided by 2 and then split to the left and to the right. But when we're doing it dynamically, once it's already been drawn and we're incrementing the width, what we're doing is we're incrementing the position of the right edge of the box, right? And I can maybe show this a bit better. So if I have a reference, if I take a reference to bar, and I know that the bar, assign it to bar, I can show you this in the console, basically. Actually, let me even comment on the progress again, so that we can start with the very first. This is how it will be starting, right? And then on progress, we're going to the bar.width and assign it some value. It should be its initial width of 4 plus some kind of progress from 0. So when progress is 0, this will be 0, so it will just be its original width of 4. Where was it? There we go. It's this value right over here, right? And then when progress ends up being 1, it will be all the way to the end, basically. So the bar dot width, let's give it a 10, and that's not very visible, but if I give it 100, as you can see, it's incrementing the right edge, right? So this edge over here is just the way it's implemented, right? And if I were to increment the height instead, so the box dot height, the box, the bar, sorry, the bar dot height, as you can see, that's incrementing this edge over here. That's an implementation detail, and I think that basically covers it. So what we can do at this point now, I mean, I can leave that over here. Yeah, this part over here. So if I were to loop while I'm preloading here, and I assign a bunch of things to the queue as we talked about, basically I can simulate it taking some time, like assuming we have 100, 200 in this case, 200 images, which I am keying differently here, right? I'm saying like logo 1, logo 2, etc. Sure, I'm loading the same image, but I'm keying them in the cache under a different key. And doing so, I can now refresh. And as you can see, this is how it would look like if you actually had something heavy to load. So that's why, going back full circle to the initial discussion of you would load the assets you need in the preloader and the boot scene, right, the background, so that you would have something to show. If our loader were a bit fancier and it required some other assets, the boot scene would be where we would load those assets. And once that's done, we load the preloader, and here's where we can go ahead and load the bulk of everything, basically. Okay, so I think that's it for this lecture, and yeah, I'll catch you in the next one.